PC activity 7. For the first part of the chart where particles are consistent, I put that liquids, due to the temperature they have a change in speed, attractions or collisions change speed of their movement, and the solids have kinetic energy and change in temperature, so we know they are colliding. For the second part, particles are separated by some amount of space. Gas particles are compared to the size of the particle size, we know that particles compared to the size of the particle is, so we know this due to the simulator. As far as liquids, from our simulator, we know the particles are close together compared to the size of the particle. For solids, the particles remain in a close clump. We have seen that in the simulator as well. For particles constantly vibrating around a fixed position, gas particles tend to always be moving around, very rarely ever stagnant in one position. Where liquids, the ones that are close together, vibrate against each other as seen in the simulator, and the simulator also showed that solids remain in a clump vibrating against each other. So then for the next part of the graph or chart, the space between particles is very large in comparison to the size of the particles. Gas, they tend to be far apart from each other compared to the size of the particle itself. Where liquid particles tend to be close together compared to the size of the particle itself, and solids, from the simulation we saw, they tend to stay close together in a clump. For particles collide with some attraction between them, I put gas do have collisions with other particles, but they clump, do not attract other particles. Where liquids and solids, I was supposed to put X there, I forgot. They do attract other particles and collide with other particles as well. For the next part, particles have kinetic energy. Gas particles have kinetic energy. We can measure temperature and speed of gas, so they have kinetic energy, as well as liquid and solids. We've seen that they all three have kinetic energy because their temperature and speed can be measured. Particles are strongly attracted to each other. Gas particles are not attracted to each other. They don't pull towards each other, while both liquids and solid particles are attracted to each other. And the space between the particles will increase as the substances are heated. I should have put an X by the solid, but all three, that happens. Gas has kinetic energy particles and do get faster when heated and slow down when cold. Liquids have kinetic energy particles, so they do change with temperature, and when heated, they increase. That's why the ocean rises. And the solid particles increase when heated because the object itself also increases in size. So then, on to the questions. Number 2, I would hold the lid under the cold water because it shrinks the object, or the volume, particularly if you ran the lid under hot water, it would increase in size and volume, while cold water would decrease the size. So for number 3, I put the beeswax starts at 25 degrees Celsius. Then it is converting energy to heat up to melt. To get it to first, it has to decrease in kinetic energy and potential energy. While it is heating up, it will start to increase in kinetic energy and potential energy. And then for B, I put the beeswax is receiving energy during a heat interaction. Since it has now reached melting point, there is no kinetic energy and the potential energy increases. For this diagram, for number C, I was a little confused on how to do it, but this is the way I drew my diagram, and I put the beeswax starts at the melting point, but the energy has to be taken away to decrease in potential energy, and because it's at melting point, it has no kinetic energy. Once the energy is then taken, it's continued to decrease in a freezing interaction to convert the beeswax to 25 degrees Celsius. At that point, the beeswax decreases in potential energy and decreases in kinetic energy. Again, these are the summary questions for Unit PC Activity 7.